Now you can see our timer IC is generating pulse beautifully. Now what I want to do, I want to run this stepper motor. This is a 24-volt stepper motor, um, using that pulse. So I have a driver here. This is cheap A4988 driver from AliExpress, I think. So I use this driver to run the stepper motor using the pulse coming from the 555 timer IC. This is A3988. So if you look at the back of this IC, you can see step, the pin called step, that where we will be applying the pulse coming from the IC. Then we will sleep and reset tie together. Direction, you can connect it either to positive or to negative. Which just to change the direction. If you connect it to negative, it will rotate in one direction, and if you connect that to the positive, it will just connect to the opposite direction, like clockwise and anti-clockwise. Then ms1, ms2, and ms3 and the enable, we will connect all of those to the ground, so this driver will generate full steps instead of half steps or quarter steps. That depends on the combination of ms1, ms2, ms3 logics, like 101 or 111 or 000, which is like we are we are connecting either to negative or the positive terminal. So I'm going to connect all those to ground, which is negative, so I'll get full step. Then on this side, 1A, 1B, 2A, 2B, that is the output to the stepper motor, and ground or obvious. Then V mode is 12 volt, that I will be using to run this stepper motor, and VDD should be 5 volt, which is, as I said, manufacturer recommended voltage. Okay, let's put this on the breadboard. Let's take out that LED and connect the pin 2 to the output of the um, timer IC. So connecting pin 2, which is, make sure the pin is correct, pin 2 to the output coming from the timer IC. And what I want to do, I will be connecting the direction. I can connect either to positive or negative, it doesn't matter, depends the direction, rotational direction. So just connect it to the positive, which is okay. And if I want to rotate the motor in the opposite direction, I can just change it to the negative rail. That's it. All right, then the next two pins over here, these two pins are sleep and reset. I'm going to connect those together just using this pin. Then now I want to connect all the other four pins, enable ms1, ms2, and ms3 together, and I will be connecting that to the ground. So let's connect ms3 to the ground. Now we can join all the other pins together. Let's use this small pins like that. Go there, just join it together like that. Right, and the last one. I showed these four pins together, enable ms1, ms2, ms3, and that connected to the ground, and sleep and reset connected to connected to sleep and reset connected to together, enable is to the ground, and step That's where the output from the timer IC is coming and going into the driver's input. And the last pin here, that's direction. I just randomly connected to the positive to get a direction of the rotation. If I change the direction, if I change the polarity, I'll get it just rotate in the opposite direction. Now let's give the power input to the driver. So this pin is the ground. So I'm connecting that to the ground. You have to be very careful when you give the connection to this each pin, otherwise it can destroy the driver IC. It happens to me, so should be very careful. And VDD 5 volt, I'm connecting that to 5 volt rail. Then next 4 pins, if you look at the driver, you can see A1, A2, 1B, 1A, 2A, 2B, 4 pins in the middle. That goes to the stepper motor. I'm just using this pin for easy connection. So 4 connected together like that. There I can connect my stepper motor to that. Just like that. Let's connect that later. Now this last 2 pin, if you look at it, the last 2 pin are V mode. So this is the input voltage for the stepper motor. So let's keep it a little further. It's too congested. Using a wire to jump to some further point. That is the positive, and I will be connecting the negative of the ground to the ground. This is the common ground. And between this V mode, that is the input voltage of the motor, and the ground, they recommended a capacitor 100 microfarad. I'm just using a 220 microfarad, I guess, which is okay. Situation. So let it be like that. Now I can. That's pretty much ready. Now let's put the stepper motor on those 4 pins over there. Let's put it over there. Okay, before that I want to see the pulse coming from the our timer IC. So I'm just putting an LED at the output to see the pulse. Let's put current limiting resistor. This 220 ohm current limiting resistor. It was there before, so just connecting that to the ground through current limiting resistor. I'm using this little socket where I can plug 12 volt for the motor, and let's connect the other end to the V mode and the ground. So this has to be very careful, otherwise you will burn your timer IC. Not timerize your driver, because it's very sensitive. You don't want to change the polarity in the opposite direction. So it looks like positive going to V mode and the negative is going to the ground, common ground. All right, so I guess our connection is ready. Now we can apply 5 volt and see if the timer IC is outputting a pulse signal. Everything is good so far. You can see timer IC is generating a pulse, which is going to the second pin of the A4988 driver. Now we only have to apply the voltage for the motor to run. We're gonna do that. Hopefully it will work. Okay, it's not working. Let's troubleshoot. Okay, the problem was this supposed to go on the negative rail. So now you can see it's running. Maybe you'll connect the enable to the negative rail. You don't want those pins to float in. Okay, now the stepper motor is beautifully pulsating. You can see it's rotating. Okay, let's put this wire over there to see how it works. And now what I'm gonna do, I'm gonna increase the pulse frequency and see what happens. Increasing the pulse frequency. Now you can see it's spinning faster. That's the maximum frequency I can generate using this capacitor. I want to change that capacitor with a lower value. It's like 47 nanofarad. Let's see what happens. So let's change the capacitor. The lower value. Apply. Now it is humming. Probably the frequency is too high for the stepper motor. The maximum it can handle is 1000 pulse per second. So I'm gonna reduce the input a little bit. You can see it's running very smoothly. It's quite interesting. Let's increase the speed by adjusting the frequency, adjusting to a bit or higher. Looks like that's the maximum I can go. Go further. The speed is quite higher. Let's go further. Okay, now the motor is stalled. Let's go back. So which means if you go beyond a particular frequency, this motor will stall, which depends on the design. Sometimes depends on the voltage that we apply on the motor. So many factors. Let's go further. So that is it. That's a cool experiment using 555 timer IC to run a stepper motor. Hope you like the video. If you like it, give me a like and comment and subscribe to my channel too. Thank you very much.